All right. Hi, everyone. Okay, so can you guys see my screen properly? All
Yes.
good? Okay, perfect. Let's go. Hi, everyone. I'm Adam Fattal, and thanks for inviting me, Alberto. So today I'm going to be talking about haq.ai. It's a platform that my colleagues and I have been building for the past 3 or 4 months. So yeah, just before I begin, like a quick disclaimer, this isn't going to be very like formal, like the other talks. So, like if you want to interrupt me at any time, you can go ahead if you have any questions or anything. And again, it's not going to be technical. I don't have anything technical prepared. It's just going to be like a showcase of haq.ai. Okay, so let's begin. So first off, I want to talk a bit about the Eigen solvers, who are the people behind this project. So we're essentially a group of students who have heavy interest in quantum computing and stuff related to quantum computing. So and we frequently find ourselves working on things together. So we figured, why not? We put a name on it. And yeah, so I guess Min and Emilio have worked on some circuit decomposition research a while back, and now we're all independently working on different research projects. And again, we have a few quantum education things we've done. For instance, 3 months ago, similar to this hackathon, we had a hackathon called TEX, the Eigensolver Quantum School. And essentially, with the issue with that hackathon, we had like 100 users, and the way we were grading stuff was very like it wasn't sophisticated at all, right? So they'd give us their code, and we'd run it, test our graders, and then we'd give them their score back. It was very hectic and it wasn't efficient. So we figured we'd sort of automate the process, and then ended up going a bit too far and building this website, right? So again, finally, we're like super open to collaborating. If anyone has any ideas, feel free to contact us. I'll tell you guys how you could do that in a bit. So yeah. So whether it's related to haq.ai or not, just feel free to email any of us or yep. So just a bit more on the Eigen solvers. So essentially, we have me. I'm Adam Fattal, an undergrad of physics at Durham University. I'm from Lebanon. We have Emilio Pelaez, who's given a presentation, I think 2-3 days ago here, on I think KSAT problems, I believe. He's a Qiskit advocate, currently taking a gap year, and wants to further his education in the QC direction. We have Filip Rikawek from Poland. He's an undergrad of math and physics at University of Warsaw. We have Min Pham, an undergrad of math and philosophy at University of Chicago from Vietnam. And finally, Mihil Agarwal, PhD student at Portland State from India. Okay, so enough about us. Let's talk about haq.ai and what it is. So essentially, it's sort of like if you guys have heard of platforms like LeetCode and HackerRank and that type of stuff, it's sort of like we took the same sort of idea and applied it to exclusively quantum computing problems. And we designed, so far we have roughly 100 problems on the website, and we designed those problems to be for all people of all levels and interests. So whether you're a beginner who just learned what a Hadamard gate was 3 days ago, we have some problems for you. Whether you're advanced and maybe specialize in a specific area, we also have some problems for you. And the problems are essentially designed in a way, again, where they're meant to supplement, definitely not replace. Of course, you should read stuff like Nielsen Schwang and the typical text and maybe YouTube videos and courses of quantum computing. But what this does is it puts you out there in the field, where we give you, let's say, certain functions of certain libraries, maybe like a quantum circuit from Qiskit. We give you some background, some information on the topic and the problem, and it's on you. There's no way around it. You have to solve the problem somehow. So that I find, and I guess many people find through these like competitions and hackathons that are always being put out there, that it's a very good way to learn and improve your skills. So we just put it out there where it's problems permanent all the time. You can just go ahead and create your account and solve whatever you want. So currently we're supporting Qiskit and all these other typical sort of data science packages like NumPy, SciPy, scikit-learn, all these things. And but again, whether we're going to expand to stuff like Circ and Q-Sharp and all these other SDKs, like we're not making that decision now simply because we don't want to be the people who make that decision in the first place. We want it to be you guys, the users. So right now people are saying, okay, they're fine with Qiskit, they prefer working with Qiskit. But if at any point people decide, we want some Circ stuff, maybe you get to choose which platform you want to use, we can go ahead and implement that. So it's just a matter of what the people want. And just finally, before I demo the site, I just need to warn you that we're currently in a beta stage. We launched only 5 days ago, have only like 200 users, I think. And so we currently have we're building the next version, which should launch roughly before New Year's. and will be like orders of magnitude more sophisticated than what we have right now. Let me just give a quick demo. Can you guys still see my screen or?
Yes, all good.
All good? Okay, perfect. So you go to haq.ai and let me log out. Okay. So again, you're welcomed with this home screen. Okay, so who's Hack for? Again, enthusiasts, students, educators, hackathon. So if you want to host your own hackathon on the website, where we have ways and are working on different ways to do that. So if one of you guys have something like that, you can go ahead and contact us. And the challenges we have so far is we have the Eigen solver challenge and the NumPy challenge. I'll talk about both in like a minute. And again, for the people who don't really have experience with quantum computing, those are some 3 good resources we put out there. We have the Qiskit textbook, which I guess is infamous for learning QC and in a more in a balanced way between applied and the theoretical stuff, which is again what we're trying to do here. Text, the thing we did 3 months ago, it's like a 5-day workshop with a hackathon at the end, and Nielsen and Schwank, the Bible of quantum computing, right? So again, if you want to contribute, again, we want this to be as open as possible. We don't want it to be whatever we want. So if you want to contribute, if you want to create some challenges, create some problems, if you have a group of students you want to sort of introduce to the platform, go ahead, join the Discord, contact us. We're on LinkedIn, GitHub, Discord. I'll tell you about how to contact us later. And finally, we have the man himself, Paul Dirac, asking us whether we're ready to start hacking. So if you want to create an account, you can either verify your email, create an account like that, or sign in with GitHub or Facebook. I'll go with my Facebook account. And okay, so here you're first redirected to your dashboard, where it says the number of challenges you're enrolled in. I'm enrolled in 2 challenges. I've attempted 57 problems and accumulated 543 Eigen tokens. So Eigen tokens is kind of like XP points, where the more problems you solve, the more Eigen tokens you get, and the more complex the problem is, the more Eigen tokens you'll be rewarded. And we also have this very, I guess, early stage badge system, which we really plan on improving it. So as you can see, whenever you get a certain badge, whenever you do something in particular, you get a certain badge. So as you can see, if you're a graphic designer, by the way, please contact us, because as you can see, they're not exactly beautiful images here. So, but yeah, that's pretty much it. So this is essentially where like all the magic happens. You have the Eigen solver challenge, and sort of like the slogan of this challenge is that we attempt to survey intermediate level quantum computing with around 75 problems. So again, stuff ranging from quantum error correction to quantum machine learning to circuit decomposition, maybe some applied algorithms. We have tried to diversify the problems as much as we could. Okay, so here's how the thing works. You have a background. So we're teaching you, okay, so there's this unitary. We want to build a quantum circuit, which evolves the state from a 0 state to this state using this unitary. And again, as I'm sure you guys know, it's done by implementing a Hadamard gate on the 0th qubit. So if you run that, you'll get that it's correct, and you get 2 Eigen tokens. But let's say you made a mistake, put an X gate instead. You'd either get one of our custom errors, wrong circuit, wrong number of qubits, that type of thing, or you'll get maybe some Python error, like a syntax error, because I forgot this, what do you call it, parentheses. Okay, so yeah, so the intro chapter is essentially concerned. So what we try to do here, is we try to come up with we wanted to narrow the fundamental concepts necessary to solve the rest of those problems into 20 questions. We try to compress it, and those are sort of the concepts we came up with. Stuff, quantum superposition, 2 qubit gates, quantum Fourier transforms, introduction to quantum error correction, what it is, correcting a facelift. Shouldn't be showing you the answer. And yeah, so next we have the easy chapter, and this again has 20 questions. Essentially what this is it gives you a bunch of easy questions. They're not too hard, but it's essentially using a combination of those concepts to solve actual problems. So those are just more like a learning thing. Again, if you're like 2 weeks into quantum computing, this would be pretty helpful, I hope at least. And but those are actual sort of problems, algorithms like Deutsch-Josa, Bernstein-Vazirani, maybe optimizing a portfolio with a quantum computer. And then here you have medium problems, which are similar to the easy problems, but in some cases you'd be required to maybe read a paper or two to solve it, like this Fourier adder question. As you can see, you need to read this famous paper to solve it. And again, maybe you could figure it out yourself, but then that'd be pretty impressive. So finally, you have the hard one. With this account, I haven't even unlocked it. So as you can see, the thing we're doing is to go to chapter n+1, you have to solve 70% of chapter n. We did that to be maybe a bit more interesting, but again, it's very easy to remove that. So if enough people tell us we want to have all questions unlocked, we can do that. So next up, we have the NumPy challenge, which, okay, so sort of the claim to fame to this one is, let's say you barely know quantum computing. You're fresh into QC. You barely know anything. You maybe don't even know what a tensor product is. So what this is concerned with is teaching you the building blocks behind the mechanics behind what goes on behind those quantum circuit simulators like Qiskit Air and stuff. So you start off with, let's say this question is concerned with preparing some zero state as a NumPy array, and then putting the output of an X gate, the sigma 1 matrix, on the zero state, which would be a 1 state. And then eventually you build up using the 4 postulates of quantum information. You'd eventually build up to this question, right? So this question is essentially, so we give you NumPy, we give you these instructions, and you're on your own. You have to construct your own quantum circuit simulator similar to the Qiskit Air ones, right? So again, I think this is correct. Yeah, it's correct. So you get 20 Eigen tokens for this one, for instance. And so far, those are the only 2 challenges we have now. But what are being prepared right now, or I think we have 4 challenges being prepared. And by the end of next week, we'll have 2 on top of those. One of them is a pulse challenge, because none of those questions have pulse. It's all like high-level circuit stuff. So we're going to have a pulse challenge, and we spoke to IBM and got permission to put their entire, what's it called, the Qiskit Global Summer School. We're going to put all the problem sets as a challenge, a quantum machine learning challenge. So that's what we have next up. But again, we have tons of more challenges on the way. So finally, let's say you like this idea, you want to contribute, you want to be a part of it. You can either do that formally, put a sort of a proposal here. Maybe you want to change something. Maybe you want to build your own challenge. As I said before, let's say you have a group of students that you want to sort of like build some small group that uses this. Whatever it is, we give you a few ideas here, but if you have your own thing, then we're again very open to it. You can either put a formal proposal here, or again contact us wherever you want. So if you want to join our Discord server, you can do about us and this little thing here. So you could contact us here, or again at maybe Adam at haq.ai. You can contact me here, or maybe even contact, that would be perhaps be better, contact at haq.ai. So this would essentially email all 5 of us, contact at haq.ai. So yeah, so this is pretty much all I had prepared for, maybe a 15-minute demonstration. Maybe if you guys have any questions, we could have 10 minutes for that. So does anyone have any questions, or? Oh, sorry.
Igual uno de los compañeros de esa plataforma es uno de los talleristas que fue el de Oracle, Emilio. Entonces, igual,
Sí,
igual, pues si quieres dar un poquito de extensión a este taller para que se motiven más, digo, de esa plataforma.
Pues sí, bueno, pues todo lo que dijo Adam, y también uno de los challenges en los que estamos trabajando es que nos dio permiso Qiskit de añadir todas las preguntas de la Summer School que tuvieron Machine Learning. Entonces, actualmente pues estamos trabajando tenemos que crear nuestros propios graders para eso, pero una vez que esté eso preparado, pues vamos a poder añadir todos los problemas que estuvieron en esa Summer School. Entonces, pues eso también va a ser una muy buena, pues una adición muy buena a todos los problemas que tenemos.
Igual pueden considerar esos problemas para su hackathon, para propuestas de ideas. ¿Emilio?
Sí, claro. Sí.
Perfecto. Adam, I had a question.
Yeah, sure. Go ahead.
I had interested. How many people and around the world try to contribute in this platform?
Including yourself, it would be around 15 so far in total. That's between web development and again building problems, maybe testing a few things. Yeah, I think it would be around 15.
Okay. And do you think it's necessary try to understand all quantum computing, like, I don't know, try to study before a book, or we can help us with your platform? Try to learn about another, I don't know, online course or summer school. What do you think? What is better about your platform?
Right. So again, we're not trying to replace that. We just want to supplement it. It's just like something that's always out there. If you want to solve a bunch of, again, there could be a Jupyter notebook that has this that has a bunch of problems. There's nothing wrong with that, but this thing is just some centralized platform where you can keep track of your progress, maybe compete with a couple of your friends. And again, this is just the first version, and a lot of features we have under development are being realized right now. So yeah, I think that's about it related to.
Okay, thank you for your answer. Thanks a lot, Adam.
Thank
I
you.
don't know if other one has any question about the problems, the complexity. Bueno, en español, si alguien tiene alguna duda de los ejercicios, de la complejidad, son ejercicios muy básicos. Algunos son introductorios, no necesitan saber nada de computación cuántica, en el sentido de que es puro NumPy. Y más adelante, conforme el nivel, pueden ir analizando los algoritmos más populares, como bien lo mencionaron. El Bernstein, Deutsch, el Grover y demás estructuras. Igual lo mismo que como que enseñó en el curso Emilio, Oracle, igual les puede servir, o aplicaciones. I don't know if, Adam, do you have cryptography or application?
Yeah, we have a few cryptography ones. I think we have 5 out of 5 of them. No, 7, sorry.
7, okay. About quantum machine learning, do you have?
Was it? Okay, we have 2 sort of optimization ones, and it was and I think 5 quantum machine learning in the Eigen solver challenge. But again, we plan on building challenges for each of the, like, let's say you want like specifically to learn about quantum error correction. We want to have like a whole quantum error correction challenge. We want to have a whole quantum machine learning challenge. Is for each of those individual topics. So that's why we were looking for more specialized people to build the independent challenges. You know what I mean?
Okay.
So yeah, quantum machine learning is pretty much what's next up from the IBM school, but we plan on building stuff again on top of that. So.
Okay, entonces igual si quieren proponer su proyecto para parte del hackathon, extenderlo y que la gente lo analice, pueden proponerlo en la plataforma de haq.ai. No sé si alguien más tenga comentarios, dudas, pueden escribirlos en el chat. Creo que no, ¿verdad? José.
Thank you very much for having me. It was pretty fun. Thank you.
Thank you, man.